probably will realize, even the guys who look at requirements analysis, they have to think about it. It's not just the end product. You have to think about the security and the whole process of your project. Yeah? Maybe you will never do it in future life. Maybe you will become something else completely. But for your final year project, maybe you won't even implement certain things. But I think your supervisor would like to see at least that you have thought about security. Yeah? I had one student who emailed me, I'm going to build a website, people will put their name, blah, 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 and something will happen. I don't see where security is, he said. Well, first of all, I said, are you really third year? And you know me, the people who know me, I'm extremely sarcastic, so be careful. Okay? So, can you see security there? Of course. You don't want all the people who join your rock climbing app or whatever that they have registered to lose their emails and their usernames. Yes? You need to protect them. When you ask people to register on your website, that's what you do. You take a legal responsibility. Yeah? It's like, I know it's difficult. I can joke about it, but I know it's difficult to see where security fits, or also where legal and ethics fit. You know, sometimes it's very difficult to see. For example, the same guy, he said, I cannot see the legal of it. Well, you're going to propose, let's say, I won't say much, so I won't pinpoint who he is or she is, but you're going to propose, let's say, a program of exercise, right? Depending on the data that the user has given you. What if this guy breaks his leg because of your program? You know, that's where the legal thing comes. Have you covered your back? Yeah? So, food for thought. Can you see what's wrong with this? I forgot to bring sweets, so I won't give any prizes. Except if you want the ones I have so I don't smoke. Record. Anyone?
Displaying information to the user.
Sorry?
Displaying information to the user.
Such as?
Well, much everything. Even typing.
Yeah. Very good. Yeah.
This is debugging, so I'm not sure if it's supposed to be showing up.
It's an example, okay? If I see this, I can see the structure of your database. And most of you are probably more experts on databases than me. But also, I see this. Can you see this? I can see the directory structure of your system. Yeah? What's wrong with this? You try to log in into your laptop, too specific. That's why they never tell you if it's your username or your password. They tell you something is wrong. Yeah? Again, what is wrong with this is the whole structure. You know, I'm trying to get validation.txt, and I'm trying to go to this directory structure. So you are giving me ammunition, yeah? You're telling me more. For example, if I tell you that I bank with Lloyds, right? You already have one piece of information about me you didn't have before. Yeah? That's what I'm trying to say. What's wrong with this? And again, I have very good coders here, especially this lady, who will tell us what's wrong with this. If you can. I'm not picking on you. If you can. Oh. Okay. How do you know about this? I cannot make it bigger at the moment. Except, will it help if you sit in the first row? No. Oh. Can you see anything wrong with this? It's not a test. I'm not going back to your tutor saying, oh, she failed or she failed or whatever.
continuing with our file.
Okay. Let's start with things like variable contents and environment not initialized. Because the attacker, if you don't initialize your initial variables, right, they might find a way of initializing them for you. Yeah? If they get in. Security.dat is not full path name. Therefore, like in opposite to what I said before, that I had the full path, here, again, if somebody is trying to get into your system, he or she only has to replace security.dat, not the whole structure. You might find ways of have the hidden, the structure of your directory hidden or somewhere. Okay? File security not closed. Okay. Somewhere we open the file, yeah? We never close the file, yeah? And error message indicates file name. That gives more important information. Any security errors here? Password is hard-coded. I don't want to see password icons in your code, yes? If I see that, then I automatically not fail, but I give a very low mark, okay? You don't hard code. You should always encrypt, and it depends how you do it later on with that. Total, it says may overflow, producing very small number. Input is not checked, could be 0 or invalid. Here, the count, if somebody puts 0, the total will be 0, yes? Because you multiply with 0. Is this something, I mean, these are just examples, okay? But what you have to think, if you are writing code, is this kind of things, like I don't have code password, I initialize my variables, I close my files, if I open files, and encryption should be standard algorithm. Don't think you're that clever to write your own encryption. Use what is known, right? Don't start thinking you're better than what you are. You might be in 5 years or 10 years, but at the moment, don't oversell it. Use existing encryption methods, right? So what is security? Security overall is the protection of information. And that can be in terms of systems, hardware, that use, store, and transmit that information. So it can be anything, yeah? Your iPhone has, or should, your servers, your virtual machines, everything has information there that you should try. The bad guy can be everywhere, right? Here, what we have, you, me, here, him, right? We communicate by Wi-Fi or whatever, right? We use the system through the web page of an Oracle database, right? Here, I can come with my laptop and sit around, and if I have the appropriate software and antenna, I can start intercepting communications. An example I used to do to cyber students many years ago is when even Google Gmail was transmitting the password in text. Yeah? It doesn't do it anymore, thankfully. Okay? But somebody can sit there and intercept or hear, right? Somebody can try to break your wireless system. Somebody might try to break into your Oracle database, etc. And whatever language you use, there's no, usually, I always hated pointers as a student. I never understood pointers. So I try to avoid languages that have pointers, okay? So, sorry, that's me. So whatever language you use, there's something wrong there. Something, if you don't close the hole, you will have problems. At the end of the day, we all build software, yeah? You're building a on PHP in a web platform. These guys are creating the requirements for somebody else to do it. You're creating an app or something. It's all software, yeah? And this is, as you have probably they bombarded you since day zero, this is the software life cycle. You go and talk to people and get requirements, yeah, of what they want to build. You then design. I assume this is more information systems kind of people. Coding, anyone, CS, whatever, software engineers. Testing, deployment. And this is a circle. I remember when I took, many years ago, one sabbatical. I went to a company, and I really wanted to go back to programming all this a little bit for 6 months. So I said, I don't want to do a lot of coding. I'll go to your requirements. And I really enjoyed it. I love talking to people, and I love getting to know people. So it's also what you do, a personality trait, yeah? If you are a very reserved, in the corner kind of guy, you're not going to enjoy talking to customers, are you? And of course, when requirements, it's very important in my opinion. Very, very important. Because I remember having an exercise with students, and I used to say to them, build me a simulator of a vending machine. Right? Nothing else, that's it. I'm the customer, I pay, that's what I want. It was their job to come and talk to me, to arrange appointments. So I had one group of people, there was a group work, that they built the best software. It was selling Coca-Cola, Pepsi, Fanta, chocolates. They didn't get us a good mark as the people who only sold, the vending machine sold Coke, Coca-Cola, because that's what I wanted. But the other group came to talk to me, yeah? And they said, what do you really want to sell? I said, just Coke. Does it give change? Yes. Does it accept paper notes? Yes. Can you see? So that's why. Anyway, I'm diverging. But this is very important. Okay? But everywhere, you will have security. So, security requirements here. Use cases. You will build use cases, won't you? Yeah? What happens? Yeah? You will have risk analysis on the design. So even if your project is not to build, to code, you have to think about these things. And I do give every now and then various references and etc. for you to start reading a little bit about it. Remember that you have to show that at least you appreciate. At least you appreciate it. If you create a use case and then you pinpoint the security issues, you will get a better mark. It's obvious. Yeah? Static analysis tools there. Penetration testing. People are building a website. Yeah? Is it a website or
Application.
App?
Yeah.
Okay. Website. I can come with my laptop and see if I can break in. You have to think about that. You know, usually I mark projects of the cyber students, but I always have 3, 4 of CS or IES or software engineer. And I always find it amazing. People spend time in telling me how beautiful the buttons look. Okay? I don't give a damn about these things. I prefer to have something functional. I don't expect something beautiful, you know what I mean, in terms of. But also at the same time, human interaction, it's very important, yes, if that's your project. But if your project like this lady is something functional, I wouldn't expect it personally, maybe your tutor says differently, to spend all this time in making a lovely website. You know, I prefer to see something functional rather than something that looks good but does nothing. Yeah? No time to cover everything. Here are some, if you are doing Java, there is Java Coding Guidelines book, and various other books. Here are these available already on Study Space? Is my slides available? Not yet?
I think the slides are.
There? Okay. So you can have this, you can go and read more if you wish. When we talk about security, sometimes maybe I did say penetration and all this, but also it's physical security, okay? Maybe not very important for final year project students, but our computers up in the labs, they used to, I don't use these labs, we have our dedicated lab now, so I don't know. They used to be locked with chains, yeah? Do they still do that? Physical security. You will have people walking around, or you should have people walking around and say, where's your ID? What are you doing here? Are you student, staff, academic, secretarial, whatever? Yeah? Personal security, or just operation security, and all this, network security, we must have policies. Then you have signed. When you first joined Kingston University, you did sign various documents, right? That, for example, you are not allowed to install software on our labs, yeah? Awareness. This week they have the cybersecurity awareness, yeah? Etc. If you don't come, I'm giving a very short talk tomorrow about it. They used to say at Kingston University, you must change your password every 6 months. Yeah? That was a policy. They don't do it anymore. Wrongly or rightly, I don't know, but they don't do it. But that's the kind of policies. Awareness, training, train people. You are computer scientists. If you receive an email from Lloyds Bank that you have £3 million deposited from the Prince of Arabia or whatever, you won't believe it, or something like that. But there are people, elderly people maybe, or people who are desperate for £3 million, or whatever, who believe and click, yeah? So you have to train people, educate people, and use the appropriate technology. And what we are trying to do with security is prevention. Prevention is the best medicine, in my eyes, of trying to prevent attackers from violating your own security policies. But, as I always said, the best people are the black hat people. They seem to know the systems better than anybody else, and they might get in, okay? How do you detect that? That's another goal of security. How to detect that somebody has violated my own policies. And thirdly, is to recover. And when you recover, this might take, you might have policies there, but what I mean by recover is that if your server has been taken over, have you got a backup server? So you can switch off this, isolate it from the network, and switch use the other server. Because if I'm a major bank, I don't want to say my server is down, do I? Because people will take their money to another bank, yeah? And this is various terminology. I'm not going to talk about all of them, but asset is something that we need to protect. Asset in this case is my laptop, yeah? It doesn't have to be hardware, of course. It can be an idea. It can be the blueprint of a new nuclear submarine or something, yeah? That's an asset. Exposure is possible loss or harm to a computing system. Vulnerability is a weakness in computer-based system. And let me show you an example. A city like Kingston, let's say, is vulnerable. Yeah? I don't know if this is true about Kingston, but I'm just saying. Because the location is below water level, and we live, okay, it's not Kingston. Let's say another city, somewhere in the world, that it's below water level, and it's in an area of hurricanes, yeah, storms. Therefore, automatically, this city is vulnerable. And what threats do they face? Well, hurricanes, dam damage, terrorist attack, who knows? But here, if this is correct and I'm vulnerable, therefore the threat is that the hurricane will come, will destroy my dam, I will have floods everywhere. I mean, for crying out loud, in England it rains 2 days and we have floods. Yeah? Okay? And then how do you do that? Well, you have controls. You can build higher dams or stronger dams or other infrastructures. You can have emergency response plans. You can buy more, not planes, a helicopter, thank you. You know, to rescue people, who knows, you know? But can you see, everybody is vulnerable, right? For some reason or another. And you say, right, my web page is vulnerable. What kind of threats am I having? You know, will somebody try to get my login account? Yeah? And of course, here again you have various categories of threats. That's acts of human error or failure. You know, accidents, employee mistakes. There's nothing really you can do if I take this coffee over your laptop. Yeah? You cannot protect it. You cannot have your laptop in a bubble all the time, right? But accidents do happen. Deliberate acts of espionage or trespass. That means unauthorized access or data collection. So is this something that rings, or one of them, that rings a bell about your project? You know, will somebody try to get unauthorized access and collect your data? I don't mean it will happen. What I mean is it possible? Is it probable that somebody might do? And if you say yes, then you say, how can I prevent that? Yeah? Anything else? I mean, software attacks, viruses, worms in other service. Last year, I think Kingston was down for a day or a half or something like that because of a denial of service attack to Janet. Yeah? And Janet is the university's network, and it was attacked, so a lot of universities were down. Yeah. Can you protect? Maybe not. But I don't know if people will try to put a virus inside your website or whatever. That's what can happen. Some common attacks is like this. Social engineering. If I come very innocently with my hat as a lecturer and say, right, which bank do you use? And you tell me. And sometimes with the first years, I say, okay, what is your password? And they tell me. Yeah? Because they believe me, they trust me. Yeah? And that's what I'm saying, that you should not trust even your granny about passwords, etc. Right? Spam, we all receive spam. Yeah? Spoofing and man in the middle is more penetration testing kind of what we have been taught, but man in the middle, I pretend you two communicate and I'm in the middle pretending to be her. So you give me everything. Yeah? Password cracking. Tomorrow I have a couple of videos to show people how easy it is to. You don't have to even have a computer science degree to download a few pieces of software from the internet and start cracking. But in order to crack his password, yes? Can I do it? I have the best software to crack password. Can I do it?
Eventually.
No. Eventually, if you are silly enough to give me a backdoor to your system. If you don't click something you shouldn't click, if you don't leave your laptop away to go to the loo, and I can put a USB there, which copies all your keystrokes, if you don't make the mistake, I cannot get in. Can you see? Eventually I will break, yes. But in order to break a Windows password, what should I have? Access to a file called SAM. Okay? Yes? So always, the point of the story, the moral of the story, is yes, we can break passwords, blah, blah, blah. But if somebody doesn't make the mistake of giving me a backdoor, something to go in, yeah? Coming back to the 6 months, it has been estimated that if you have a very, very good password, it will take almost 6 months to break. Yeah? If I have access to a lot of computers and okay? That's why people used to say change every 6 months, because by the time you have broken my password, probably I have changed it. Yeah? Can you understand the terminology of confidentiality, integrity, and availability? I assume, is it Beryl who does databases? Yeah? I'm sure you have come across these terms, yes? Confidentiality, information about a system or its users cannot be learned by an attacker. And I think I have an example of all these things, what I mean. Integrity, if you're building a database, for example, gender can be M or F, yeah? What if I put the age? Your system should not accept that, shouldn't it? So what do you do when you did your Oracle SQL and all that? What did you do? You put constraints, didn't you? Something like that. That it will only accept M and F, or male, female, or whatever. If I put integrity, if I put age 232, the system will accept it, won't it? But something is wrong there. It's either 23 or 32 or whatever. And again, hopefully, when you were going databases, you were putting limits. That's, age cannot be more than 110 or something. Yeah. And availability is like the major bank. We want to have available our balance at all time. Yeah. Authentication. Again, there is a difference. Authentication is verifying users' identities. Who is this user, right? Something that you do. What a user is, what a user has, and what a user knows. For example, when you go to study space, it's a one-factor authentication. You put username and password, yeah? If you go to an ATM card downstairs to get some cash, you have the card, which authenticates, but also your PIN, yeah? So authentication is the first thing. If I walk here, I say, hi, I'm Dimitris, I'm giving a talk. Except one guy, the rest of you doesn't know if I'm saying the truth, telling you the truth. Yeah? I might be Catherine from Alabama, as far as we know. Yeah? True? So this is what happens with the authentication. You are saying, let me in. The system comes back and says, tell me your credentials. And I give my number, and I gave even more information to you now, because you know my real ID, yeah? With my password. Break. That information goes to the database. And the database says, this guy tells me that it's KB08915 with this particular password. Your password, as you probably know, is stored. I mean, these laptops have your password stored, yes? But encrypted, yes? So when it says, yes, let him in, or no, how does it know? Well, it takes what I say my password is, yeah? The access, and using the same method as before, when I first log in, encrypts it, right? And does this match what I have on my database? Yes, then go in. Does it make sense? Nobody, that's why people say, oh, I lost my password, can I have it back? No, nobody will know your password. We will know, okay, if we get access, we can find it, but we will know your encryption, yeah? But not your actual password. So, if this comes back with success, then the system says, yes, you are in. Once authenticated, what kicks off is the authorization, right? Not only now he said, yeah, this is Dimitris, let him in here, right? But now, the system has to verify what the user can do. And this can be done with various access control. Don't know if you have come across them. Anyone? No? No? For example, how does the system know when you go to a lab, you're not admin, you're a normal user? Well, the administrators have created access controls, right? And this says, right, when KU08915 comes in, he can come in as a normal user, and I have these rules. This guy can access A, B, C. No D, no E, no F, no Z, right? Or data owner. For example, if you build an Oracle database, you can build in access controls, who has access to what tables, and who can update and delete tables, yeah? So, the moment Dimitris is in the system, here, okay, I have access, for example, to my documents, yeah? Which we all expect, yeah? And I have access to Microsoft software, and I might have access to an FTP server. But I do not have access to SITS. You don't have access to SITS, do you? SITS is a system, a software system that has all your 3 years information, where you live, your mom, your dad, what A levels came, you know, whatever information. Well, I cannot access it. I can, but I can access a portion of it, right? The secretaries can access more. I cannot find your home address to write to your mom and dad. The secretary has this to send you the results, right? So there are, can you see the difference between authorization, yeah? What authorization means? It means what facilities within the system you're allowed to use. So in this silly example, I cannot use administrator document and SITS program. When you build applications, you have to consider various ways of security. And we are going to have a look at a few of them. Input validation, output encoding, access control, which I just spoke about access control. You know, who has access to what? Not only who gets into my system, but what they have access to. Yeah? Data protection, database security. Data protection reminds me, and I don't want for you to make the same mistake. Don't simply on legal, ethical, blah, blah section, you put data protection and you copy paste from the website what data protection is, blah, blah. If I'm your marketer, I want to see how this relates. Why are you telling me? Yeah? I want to see how this relates to your project. I know, if I want to know what the data protection is, I'll go to the same website you will. You should include it if it's relevant to your project. And if you can say, that's why it's relevant, yeah? A lot of the time, people just put information there without any apparent reason, yeah? Okay, as a programmer, you wish to produce software that demonstrates also system correctness. People who do, like I said before, I'm not going to cover every project here. System correctness. Whoa, whoa, oops. Okay. Go away. Well, what happens here is, if I write a program in Fortran, Java, C++, and I give the same input, I should get the same output every day of the year, yes? Yeah? That's what. So, here is a simple program without any I like pseudocode. Okay? Read input A, read input B, calculate A divided by B. Yeah? And you write in your own programming language this. And you say, let me test it. 6 divided by 2. It tells me it's 3. Yeah, it works. Very easy. What does it? Does it? Huh?
You should run different tests.
Okay, give me another test.
Just do B by A and see what happens.
What?
Do divide B by A and see what happens. So flip around.
2 divided by 6.
Yeah. see
Fine, and it gives you the correct answer. 12 million divided by 3 million gives you the correct answer. When will this break?
If it's not initiated.
No. You don't initiate because you said read. How can you initiate? Read means give me, yeah? So you're asking the user to give you a value. When will this break? Come on, guys. When? Any ideas? How about if the... Okay, I like your thinking, but what I was looking is that if B was a 0. Yes? If B was a 0, I'm sure you have come across this. Divide by 0 error. Yeah? No? Yes? So, it doesn't matter when you test your code, do not test always with valid things. Yeah? Because you can do 3 million valid tests and everything is correct. It's not the quantity, it's the quality of your testing you have to think. Yeah? The extremes. So what and I'm not the world's best programmer, but I will have something like an if statement. If B is not 0, then I will calculate A and B. Otherwise, I will tell you, you cannot divide by 0. Yeah? That is security. You like it or not, you think it is or it isn't, it's security. Yeah? Storing, deleting passwords. For example, if you do Java, the recommendations, and last year, when I was doing it, or the year before, is that your passwords should be character arrays. Right? You should not have them as strings. Right? Anyone is going to do Java? No? Okay. But anyway, okay. So Go, there are so many books about Java guidelines. And not only how to program, but also there are recommendations like this. Look, if you're going to ask a user about password, the password should be defined as a character array, because you can zero them. Whereas if it's string, it's immutable, so you cannot zero them. Things like that. So for your particular language, programming language, go and spend half a day reading around. Yeah? If you have passwords, put PHP password guidelines in Google. Yeah? Other search engines exist. Okay? Use assertions. Case statements. Some languages, you might go and operate the last case. Always have a default case. Always have a default case. Yeah? Which catches everything else. You have come across case statements, yes? Here is a little bit about databases. If you're building databases or interfaced on the web, etc. Here I'm saying that I can have data security policies. So you will have, what do you call it? You put, I know these days you have sticky persons, don't you? administrator, or user, or whatever you call them. Yeah. For some of them, okay, for example here, Dimitris can issue select and insert statements. I.e., you can write in Oracle, SQL, that this particular user or this particular group of users are allowed to select, I write a select statement. They're allowed to insert into a table, but they are not allowed to delete. And in this case, I'm talking about the EMP table, employee table, right? So Dimitris can go to employee table and say, select all employees that are male. Okay, I find the results. Dimitris can go and say, insert Maria, blah, 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 as an employee. But I cannot go and delete Peter, who is already an employee. I'm just making up rules, yeah? But it's not just writing SQL, doing your tables and your ER and all that. You have to think, who has access to what? You don't want average Joe user to be able to see the credentials of another average Joe user, yeah? You might have password security. Okay? And go and find out if you are using Oracle or whatever, how can I encrypt my passwords? I don't want to see projects that the passwords are in plain ASCII. You know, you have to learn. And last year I noticed a lot of people, I don't know if I influenced them through this, but the few I had read, they had used the Oracle facilities to encrypt. Yeah? You can have things like profile, which describes database resources, users' behavior, like the previous example, who can do whatever, and you can have create profile statements. Have you come across create profile statements? Yeah? Yes? Good. Yeah. Password management policies, account locking. For example, it's not only for databases. If I have a policy for this laptop, 3 times you made an error, it's locked for 2 hours. Yeah? Or 1 hour, it's up to you, right? You can have password aging and expiration. Woo! This password is 7 months. Finito. Kaput. End. Yeah? Force the user. This is your policies. Password history. These days, you go to a website and you put the same password that you have and tells you, no, you have already used this password, or a password that you used 2 years ago, and they keep a history. And they tell you, no, you cannot use it, you have to have a new one. Yeah? All these are recommendations of you to think about, if you need it for your project or not. I don't know. And password complexity verification. You know, these days you go again to websites and to register, they don't allow you to put alpha or Apple. It has to have a number, it has to have an exclamation mark, it has to have a certain size. Yeah? So this is an example which says, I only allow you 4 failed logins, and the password is locked for 30 minutes, or whatever. Yeah? Things like that. Password aging, another example. And history, you know, these are simple SQL statements. And this is what I said. Yeah. You can make your own rules. I mean, the password differs from the previous password by at least 3 characters. You know, I mean, we get a complicated life these days. Okay, I used to teach biometrics, and iPhone 6 now and 7 they have the thumb, or 5. I can't remember if 5 have it. Yeah. Is that protecting me? If you're the bloody bad guy, you can chop my finger and put it there and let it in. Yes? Yeah, when I'm asleep. Okay? Or you made me sleep. Right? I mean, there were stories about in the US, I believe, that, you know, cars that they started with the thumb. The bad guy just cut your thumb and started the car. look, if the guys want to go in, they will go in, okay? The bad guys, whatever we do. Or at least we will try. But we need to have some kind of policies, not only to protect us, but if we have a break-in, then we realize our policies were not good. So we have to review such policies, yeah? Here is a patient's table, to give you more example. Here are 3 people with an NHS number, diagnosis, with a doctor who looks after them, and various notes, okay? So what you can have, if your entities are nurses, doctors, management, is you can create rules that they say that nurses can read the patient name, diagnosis, and doctor. And they should also be able to update notes. Therefore, Phyllis, a nurse, she should be allowed to read all of this and update this. But they cannot update this or this or this. Yeah? That's what it means. Doctors can read and they can update diagnosis, doctor, and notes. So it's the same table. A management can only read name, SSN, and doctor in order to bill them, for example, or whatever. Right? But you make rules. Who has access? You don't want the nurse suddenly to change the doctor. Yeah? Not because she's a nurse. I'm not saying it as in a bad way. But certain roles have certain responsibilities. And the more we do to protect these people, the better. It's not their fault. If I was a nurse and I could write all this, if I had full access to this, if by accident I changed Patel, it's not her fault, it's your fault. The people who build systems should think about users who might do silly things. Yeah? So this way you protect. Many, many years ago, I used to teach Java, and I used to say to my first years, again as an example, take those 3 numbers and find the sum of it. Very easy, yeah? First year, first week, second week. It's a silly example. And then I would say, okay, -1, -3, -5. Oh no, you didn't tell us it can be negative. Because automatically our brain says positive numbers, yes? Automatically we think positive numbers. So when I start thinking about testing, I won't think only about positive, I will think about negatives, I will think about zeros, I will think about very huge numbers, I will think about very low numbers. This is what testing is, yeah? It's not just, I'll do 50 tests, but they are all in the normal range. What's the point? And how do you do all this? You have the SQL command grant, which, for example, here, grant select name, diagnosis, doctor, or patient, Steve Phyllis. So this particular nurse has been granted selection capabilities, yeah, for these columns, right? Does it make sense? Okay, 95% of web apps have vulnerabilities. And if you read about, you're talking about cross-site scripting, SQL injection, parameter tampering, poisoning, database server, web server, buffer overflow, all sorts. Yeah? Good fun. Yeah? Smoke demo. Let me see. If I create this, yeah, I create a file called test2.jcp on Notepad, yeah, and it's welcome, request.get parameter name, blah blah. Yeah, very simple. I hope it has to be simple because I'm not an expert in these things. Writing. Okay? So if I run it with Dimitris, I will see welcome Dimitris, yes? Yeah? What is JCP? Anyone knows? What is JCP file?
Is it like it's a bit like XAMPP and stuff?
It's a what?
It's a bit like XAMPP, so it's like a local server. You just do everything at once.
No, what files will have an extension of JCP? If I say to you, what files have an extension of doc, DOC, you will automatically tell me they are Word. What is JCP?
Java.
Java server pages. Yes? So, if I have this file, that file simply requests something and displays it with the message welcome. You see, if I put Dimitris, it will give me welcome Dimitris. There is nothing stopping me running it like this. And again, here he lives on my local host, okay? Ignore where he lives. What you have to look is that, whereas here I said, my name is Dimitris, and this is the normal, or James, or Kate, or whatever, Bob, yeah? Here, I say, ooh, can I put there a script rather than a name? Because this is a script. Can you see? Starts with the word script, keyword script, ends with a keyword script. And if I do that, I get that. Obviously, this is a silly example to show that if I have this Java server page, it's very easy to attack it using a script. Yeah? Inside here, I put text. I could have put another program. Yeah? Can you see? So you have to protect your web pages, if you do, web page, of this kind of attacks. Yeah? That somebody can go and put this kind of stuff. Here is another hello.get.html in Notepad. I wrote it. It uses CGI. I don't know if people use CGI these days. No? Anyway, and the method is get, first names, last name, whatever. This is just a form, yes? And here it is. I go to hello_get.html. I will see this, and I'll put Dimitris Tsatsinas, yeah? And I will submit. Okay? When I submit, this is what's going to happen. The first name will take the value of Dimitris, and the last name will take the value of Tsatsinas, yeah? Can I do this then? And if I do this, what happens? Oops. Oh, I forgot to tell you what happens, but you will see the high, okay? So one easy way to solve it is, rather than have get, is to have post. You see, if you do this kind of work, you should research, ooh, what happens to this? Okay? And this way, it won't happen, the attack. Let me put the complaint about battery. Did I bore someone? I never remember where it goes. If you look at, and this is a very good website. If you Google OWASP, you will see it, if this is the kind of project we are doing. The 10 web security threats are given as such. Unvalidated input, something you saw before. It's very easy to say, do not accept script. Yeah, very easy. then broken access control, blah, blah, blah. All this is the top 10 of 2015 at least. So, attacker can easily tamper any part of the HTTP request before submitting. That means that not only they can go to a form and put scripts, but here they can tamper, i.e. change things like the URL, the cookies, the hidden fields, the headers. And if you read about it, there has different names for this kind of attack. Tampering is very easy to do if you have the right things. You are the guy in the middle. So when you're sending something to him, I'm stopping it and I change something in order to suit my requirements. So the story is do rigorous input data validations. All parameters should be validated before use. Just because your form is sending you this, do not accept it. Validate. You should have rules to say, for example, do not accept script tags. Yeah? Do server-side validation, because client-side validation can easily be bypassed by the attacker. So therefore, what you are saying is that have a strict format of what input you are expecting and match it. And if it doesn't match, don't accept it. Validation criteria, you can have the data type, string, integer, real. If you're expecting string, make sure it's a string. Yeah? Allowed character set. Minimum, maximum length. Do you allow null? Empty spaces, whatever. Who knows? Yeah? All these are things that you should validate as the input. You don't have to do all this by hand. If you go to OWASP, there is a tool called ZAP. Captain ZAP. There, that it will do automatic validation for you. So you will provide your website, and it will tell you what you need to fix. Yeah? It will be very nice to see it in your project. Something like that. Okay? And this is how it looks. Okay? So I think I did for the Kings and the CDK. I came with 6 alerts. You know, some of them are yellow, they are not great threats. But still, something professionally kept as Kings and the CDK, it has problems. Yeah? So go to your ZAP, download ZAP, offline, or except if you're putting it online, I don't know, and check your website, yeah, and see what it tells you. Oops. So here, it tells you exactly what it is, yeah, 169 with XSS protection not enabled. But as you can see, the risk is very low. So at least all the risks here are very, very low. SQL injections, you have seen something similar. Let's say you have a log before like this. This is how you've seen this before, yeah? This is how we do it. Once you submit, what happens is this username is a text, yeah? And is assigned to uname, right? And the password goes there to upass, okay? What I would like to do is, for you to think, is I don't want to transmit this as AEK of Athens, which is the best football club in Greece, Europe, world, and galaxy. Okay, and a student of mine who doesn't know that, never pass. Okay? You can use MD5. MD5 is a mathematical formula which encrypts. Yeah? Jawohl? Good.
What that was updated.
Huh?
MD5 can't break something getting wrong, but it was updated.
You can break it, but your average German won't be able to. You have to have, yes, they have shown that there can be collisions on MD5, but You probably, if you are working at Stanford, MIT, and you have access to thousands of computers. Do you want to use SH1 or SH256? You can use it. Whatever. As long as you encrypt, I think your tutor will be happy to see that you encrypt. Yeah? You don't transmit in text. That's the point. So, what if I put as a username this? Oops. At the moment I put Dimitris as username. What if I had put this? Dash, or quote, space, or 1 equals 1 colon. It would have shown me all the users. Because 1 equals 1 is always true. This, I don't care what it is. If you remember your truth tables, yeah? Whatever that is, or something true, is always true. So that becomes true, okay? So, I don't know if I have examples, suddenly you will see all the usernames there, yeah? So you can have things like having 1 equals 1, and you will, I'm not going through all this, but all this is how you start. As a penetration tester or as a bad guy, the first thing I will do is to put this. And if this is accepted, ooh, I'm winning. And then you will try to make it a little bit more complicated to find more information. So what happens when you visit the web? You open your browser, you type your URL. The URL is saved in the browser's history on the hard disk. Yeah? Your computer asks your default domain name, DNS, to look up the IP address of the website. Your computer connects to the website server at the IP address it was given to port 80 for HTTP websites. If it was HTTPS, it would be port 443, right? This is what takes in nanoseconds or whatever when you ask for bbc.co.uk, yeah? This is the exchange between the two computer servers, okay? And then your computer requests the page you ask for. The IP address, your IP address, the web page you are visiting, and details about your browsers are stored. A couple of years now, they tell you, oh, we're going to store cookies. Do you accept or not? Yeah? Cookies are a good thing. But cookies can be a bad thing, like everything else. If I could control my smoking to 5 cigarettes a day, I would have been happy. But if I smoke 40, it's no good. I never smoke 40. Yeah? You know what I mean? So it depends how you use cookies. Cookies were a good thing, but cookies are stored in text. Yeah? Certain things are text, but you have to know how to interpret them. But it's very easy for somebody to do so. Okay? And most other pages contain other elements like pictures, ads, style sheets, JavaScript. So next time you want to ask for this page, the cookies bring it for you if nothing has changed. Yeah? Very good. So now let's say I have built my own web server somewhere. Yeah? And I have my blog or photos or whatever. I can check various things using command lines like telnet and netcat. Have you come across telnet? Yeah. Yeah? People of, young people have seen telnet. These days, when I was young, so many years ago, telnet was something we always used, an FTP or whatever, right? And netcat, I don't know, networking concepts or networking operating systems, maybe they have introduced you to netcat? No? Okay. But I can use these kinds of things to find information about the web server. Yeah? It's like if I know nothing about you, I don't know your username, I only know that you're at Kingston University. I will send an email, yeah, to rubbish@kingston.ac.uk, knowing that what I will receive, it will be bounced back. But what bounce back doing? in your own spare time. Gives you a lot of information there that I can use. Yeah? So here, if I start using things like that, and here I'm using a penetration DVD suite called Kali, yeah? If I run something like that, go to Kingston AC UK using NCAT and get this kind of information, I can see they run Apache. Yeah? If I know they run Apache, every other server they run, I don't have to consider. I know how to attack Apache. Or I can use software like Nikto, which is a freebie, yeah, about Kingston, and I can find similar information. I can find the IP, I can find what I expected, port 80, and this was last time I was running it, the start time, and again Apache. And with Nikto, you will see what probable exploits you might have against Kingston.ac UK. Yeah? So for your own website, you can run Nikto, and you might get information out of that, which tells you what kind of exploits can be. How do I correct exploits? All of you are not really have been taught on this, okay? That's why I'll try to introduce a little bit about Nikto and about ZAP, things that can automate processes. And here, if you go, for example, to this website, okay, and Nikto or something else have told you you have vulnerability XYZ, right? You put the vulnerability there, and you might get some information of how to fix that problem. Okay? So here, I found two vulnerabilities in a server. So vulnerability 724 and 3233, right? Doesn't mean anything to me. Doesn't mean anything to you. But if I go to where I said, I can find information. Yeah? About it. Again for the 3233. Okay? So it tells you why they're telling you there is a vulnerability there. There is a program called FlowFinder that examines C or C++ code and tells you if you have security weaknesses. If you're doing C or C++ programming, why not? Download FlowFinder and see what it says. And then tell your tutor, look, I've done that and I fixed it. Don't just fix it. Tell them that you have used FlowFinder. Gain some extra marks, yeah? I don't know if there is something similar. I didn't search for Java or PHP or whatever. But for C++, I have come across this piece of software that automatically will tell you that your C++ program has certain security flaws. Yeah? Okay. Passwords. Again, I mentioned passwords before. This is one way to have passwords. ASCII, yeah? Text. So the password of Ian is Tombola. Yeah? On your database, somewhere it lives. Obviously, anyone who can get access to this database file can read James and Charles and Kate's passwords, yes? Yeah? How do I fix that? Encrypt. Whatever, MD5, SH1, SH256, I can encrypt. When you encrypt, and this is the encryption, you cannot, it's not reversible. What that means is that if I know your encrypted password, I cannot tell you what the password is. Yeah? You cannot go back, right? I only know what your encryption is. The only problem with this, because you have encrypted, can you see that Charles and Ian have the same password? Yeah? Because they have the same encrypted value. Can you see? So therefore, two users have the same password, and we also see that passwords have different lengths. Because MD5 will generate, no MD5, this encryption will generate different length depending on your input. Yeah? So if your password is ABC, it will create 5 digits. If it's ABC123, we'll create 8. All this, if I know this, for example, if I knew that everything was 2, 4, 6, 8, 10, 12, it saves me. When I break your password, I would only go from 1 to 12. Yeah? There's no point going higher. So by reducing my search space, I can do it faster while breaking. Okay? But in this case, I don't want to see that they have different lengths. How about if I hash using MD5? Right? Same size, but as you can see, Charles and Ian, they still have the same hash. If I have a file and I create a hash, an MD5, yeah, and I create exactly the same file, the MD5s will be the same. The hashes will be the same. So here, I don't want to have these both the same. And then you can use what it's called a salt. Like you cook spaghetti, you cook spaghetti, you cook spaghetti, but you put a little bit salt, you put more salt, you put no salt, right? So salt is a random thing that you enter to make sure. So we have made sure using hash that they are all the same size, and now with the salt, that Charles and Ian, they have different hashes, despite that it's Tombola for both of them. Yeah? If you remember, Tombola was the same password for both of them. But because I put some salt, okay? Or if you want to be paranoid, you can hash and salt 1,000 times or 10,000 times, okay? So what you do, not 10,000 times individually, you hash the hash, you hash the hash of hash, you hash the hash of hash, etc. Yeah? If you want to be, okay? Sophos, which is a huge company, of this example was taken from yes, you know. So what this story says is that we don't want to store wherever we store our passwords in ASCII. Encryption may be not excellent idea, but I would be happy at least if I see encryption. Hash with salt is better. And how do you do it that automatically? Depends what system you are using. Yeah? More references you can find here for OSP and Oracle that I use. So never trust your input, even if it's from your granny. Okay? Thank you for listening. If you want to read more about testing guides and all that of your websites, etc., this is a very good PDF. Any questions? I only hope that I gave you some salt and pepper about your project to think. And I know I picked up these two ladies here about their websites, your website in particular, you know, but this is a very good area to gain marks. Yeah? Who's your supervisor? Paul Name. Tell him Dimitri said you are wrong. Okay, now I'm only joking. But so Porniv, but you thought about it. Yeah? Okay? Who's your supervisor?
Janet.
Janet?
It's
Okay.
fine, you can show them this video. Then take that security video.
Sorry?
We can show them this video instead. You
Yeah.
take that for security video.
You're not recording me now, are you?
I am.